Welcome to clickmyproject.com. Let us discuss about the dynamic clustering and on-off strategies for wireless small cell networks. Let us discuss about the abstract of the product. So, in this proposed work, a novel cluster-based approach for maximizing the energy efficiency of wireless small cell networks is proposed. So, a dynamic mechanism is proposed to locally group couple small cell base stations, so that is a SBS, into cluster based on location and traffic load. Within each one cluster, SBS is coordinated with transmission parameters to minimize the cost function, which captures the trade-offs between energy efficiency and flow level performance. So, while satisfying the uses of quality of service, so that is a QoS requirements. Due to the lack of intercluster communication, cluster compete with one another. So to improve the overall network's energy efficiency, this intercluster competition is formulated as non-cooperative game between clusters that seek to minimize the respective cost functions. To solve this game, distribution algorithm is proposed using which cluster autonomously choose their optimal transmission strategies based on local information. So it is shown that proposed algorithm converts to a stationary mixed strategy distribution, which considers a epsilon causes correlated equilibrium for the steady game. So finally, the simulation result shows that the proposed approach yields significant performance gains, reaching up to 36% of reduced energy and up to 41% of reduced fractional transfer time compared to the conventional approach. So the small cell network and energy efficiency learning finally got the 41% of the reduced fractional transfer and the time compared to the conventional of the approach. Let us discuss about the flow diagram of the product. So this is the overall flow diagram. So in this flow diagram, first of all, initializing the variables, and then there are three processes. One is a clustering, and another is a intra-cluster coordination, and another one is a inter-cluster coordination. So first of all, so the entire operation of the proposed method is in the figure. So this is a proposed algorithm also. So in this proposed algorithm, first of all, initialization in the variables. So initial variables are denoted by, so that are inputs, so that are u, r and pi. So for t is equal to 0, so this process is initializing the variables, and then is t by n, so there is an integer. So it is an integer if yes, the process is going to clustering, otherwise this process goes to intra-cluster coordination. So this is the t by n as an integer. So next of all, the t is updated to t plus 1. So while operation is performed in this operation, so for example it is true, the t tends to t plus 1, it's again go to the is an integer. So that is the process of this, and then clustering process. So in this clustering process, gather the distance and load information. So we calculating the distance of the process and also the load information. So calculate the s power d and s power l. So there is a source on substitution. So calculate that s power d and s power l, and then cluster will be formed. So we gather the distance and load information, calculate the sd and sl. Finally, we calculate the cluster formation. So this is the process of clustering. And then intra-cluster coordination. So in this intra-cluster operation, it has a action selection, load advertising and anchor base station selection per cluster UE scheduling. So in this action selection, we calculated the a row of t is equal to f pi t minus 1. So that is the equation in the paper, that is indicated in the 23rd equation. And the load advertising and anchor base station selection, so that is also a row power of t. So that is on base station of the selection, that is also the indicated in paper, the equation number 5. And then the cluster UE scheduling, so that is the equation scheduling of 17 to 19. So the inter-cluster operation to coordination of figure, that is the formation of load advertising and anchor base station of the selection. So the key step in clustering to identify similarities between base station to group base station with similar characteristics. This will allow to perform coordination between base stations with little signaling overhead. So while many similarly features can be used, two important ones is include the location of base station and their loads. The base station location define the capability of coordination among nearby base station, while the base station loads reflect mutual interference and the willingness of cooperation. So next we calculate a number of techniques to calculate the similarities between the base station on the location and also the node. So once the similarity graph, so that is SD and SL, are found to base form of clustering is performed, there are many clustering mechanisms available in our literature survey. So given the knowledge of entirely single matrix, any of these clustering methods can be applied. So however, the main challenge is needed to calculate obtain the full similarity matrix of the entire network. In extensions of the can be categorized into two So that is in a two subgroups, and the intercluster coordination we will calculate the row of t and u of t. So the here we update the values and finally update the load information. So finally calculate the cumulative distribution of the function and then cost of the average base station. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the product. So click the main file and then run. So all the results related to our flow diagram. First of all, the system model, and then related to the result of all the flow diagram is to be displayed. Yeah, this is the first figure. So this system model, so uncoordinated base stations. So these are three base stations. So in the three base stations, the user equipment is 1, 2 and 3 and 4. So in this base station 1, all the figures are simultaneously connected to all the three equipments. So simultaneously to this figure also. So in this base station, all the user equipments are connected. This base station. So these are the uncoordinated base stations of the process. Yeah, this is the next figure. So in this figure, the clustered base station. So the clustered base station 1 is possible to connect a user equipment 1. Otherwise, the user equipment 2. So in the base station 2 is possible to connect it with user equipment 3 and user equipment 2 and 3. In this base station 3, so this is possible to connect a user equipment 4 and user equipment 3. So this is the cluster base station. So cluster means it's a form of a group. So grouping and cluster to all the user equipment of the bases. Yeah, in this figure, so cumulative density function of the base station. So in this base station, cumulative density function. So this is 0 to up to 5. So average energy consumption per base station. So this is average energy. So these are the classical approach, random approach, without cluster, and k-mean clustering. So clustering is one type of a k-mean clustering is the process of the particular cumulative density function of the base station. Yeah, in this next figure, average cost per base station with 10 SBS. So that is a small base stations. So k-mean clustering, spectral clustering, P2P means peer-to-peer subnest clustering, classical approach, random and off without clusters. So this is the number of sense channels up to 10 to 70, and average cost per base station. So these are the average cost per station. So these are the three average cost per base station, and this is also the average of this. So this is the process of the number of sense channel by using the average cost per base station with 10 SBS. Yeah, similarly in this figure, impact of similarities on the average base stations. So distance based clustering, load based clustering, joint similar based clustering. So these are the three types of clustering. Range of neighbor node. So this is the neighbor node range, and then average cost per base station. Yeah, in this figure, impact of similarities on the average base station cost. So distance based clustering, load based clustering, and also the joint similar based clustering. So these are the three types of range and neighbor node, and the cluster size of number of clusters defined by the impact of similarities on the average based of the cost. Finally, in this figure, comparison of the average cost per base station, different choice of sensitivity. So in this x-axis, we calculate the sensitivity in 10 power minus 3, and the y-axis average cost per base station. So learning without clusters, and learning with spectral clustering, and learning without clusters, and OPCA. So the with the k is equal to 5. So these are the 30 UEs, and that is a user equipment, and 30 UEs and 60 UEs of the processing. So these are the overall running procedure for the product. Thank you for listening this video.